I kind of see agents as, at some level, just human simulators, and that's what we're all moving to. Like, we use memories such that we could pick up tasks 2 weeks later. We use memories to be able to learn from our mistakes.
There are still some technical challenges out there, people that are trying to solve. As of today, we can start with it, but to reap the benefits, it's going to take some time. What we see is people try out different tools to solve this exact problem, and I think that will work. Instead of taking all different tools that come out and see what problem can it solve.
So you need a system that can go and judge when you're done. I use it for learning. I just go on long walks with an LLM and I'm just asking it questions to try and teach me things.
All right. Today, another episode on the topic of agentic AI. I have two experts with me today, namely Sam and Ram. Welcome to the show.
Thanks for having us.
Very cool. I think to begin with, Sam, give us an introduction to yourself. What are you working on at the moment? And then Ram, you can just follow.
Cool. So my name is Sam Bydlon. I am a specialist solutions architect at AWS. So I'm in an organization called Advanced Computing. So advanced computing is kind of an umbrella term for a bunch of technological concepts that we've brought together, including high performance computing, quantum computing, visual and spatial computing. Personally, I'm on a team called Emerging Technologies, and my job and my team's job is to try and understand how new and emerging concepts and technologies like agentic AI are going to impact and could potentially benefit our traditional advanced computing customers. So I have a background, I'm a physicist by training, and I have a background in large-scale simulations of earthquakes. So I do a lot of work with customers that are running simulations for various purposes. And that's kind of what led us over the last 12 to 18 months. I've been focused almost exclusively on understanding the impacts of agents and agentic AI on these concepts. And that kind of led me to working with Ram and the Synera team.
Great. Ram?
Yeah. Hi again, everyone. So Ram here from Synera. So I'm a solution engineer and also leading our AI activities at the moment. So I work with our customers, try to understand their problems and see how Synera can add value and solution here. And also pretty much a big fan of leveraging AI in the right way to help solve these problems. And that is how, I started working with Sam, I think somewhere mid of last year on a very exciting topic that also has led us till here. I have a background in computational mechanics, so more from the world of simulation and mathematics. I also worked in motorsports a bit, in the aerospace industry, and now really excited to be working on what Synera is doing at the moment.
Excellent, guys. I think to begin with, we talked about agentic AI or AI agents, however you want to call the term or coin the term. I think it would be important for the audience to understand there's a topic of AI, then we have AI agents and then AI swarms. So maybe to differentiate the different terms, what is the differentiation between AI and AI agents? How do you see that, Sam and Ram? Maybe, Sam, you can get started.
Sure. So I usually separate out, so agents is like a long-running concept. It's been around for quite a while, but I think more recently, in the last few years, what it has focused on is the idea of large language model-based agents. So I think we all use the word agent now. I'm gonna not call them LLM agents each time, but that's what I'm talking about. So I would say like what an agent is to me is a system that is based on an LLM that decides the control flow of an application. I really like that definition. So as compared to an application where you think about like a traditional machine learning pipeline, which is a awesome, fantastic, super useful historical way of using artificial intelligence, where you have a concrete set of steps that have gone through every single time. In an agentic system or with an agent, what you really have is that large language model being tasked to perform decision-making responsibilities for how that application should flow and is responsible for taking actions. So deciding what the right inputs are to take actions. So that kind of what separates it out from traditional machine learning is that it often can be represented as, for instance, a graph where you don't have a predetermined set of steps each time that graph goes through. It's very, it's kind of determined almost at runtime based on the inputs to the system.
Ram, would you have a different definition to AI agents, or would you agree with Sam here?
Yeah, I think Sam put a really nice definition. I like the word autonomy because it's semantically more closer to the what agency actually means. So agency is the ability to act with agency to decide what happens next, or what Sam mentioned, what happens in a state of flow in steps. So I pretty much agree with this definition. I also think one distinct factor of agents powered through LLMs is autonomy, that they are not locked in a specific rule-based system, but they are still oriented for goals, but they have an autonomy by which they can achieve it.
Mm-hmm. I love that. When we talk about low-code automation, especially about Synera, so where's the benefit of combining the low-code automation, the process automation, with AI agents? So where's that strength in the combination of both? Maybe Ram, you can just continue with this.
Sure, thanks. Yeah, I think there is two layers of having a technology like low-code solving an important problem. It doesn't have to be low-code, but low-code seems to be the correct solution. So there are two things. You can actually also build a low-code process of agents talking to each other, or an agentic system. So you can also program this. So there are multiple tools out there which enable you to build the agentic system in low-code. But a significant part of an agent here is they have an ability to use a tool. And Synera is a platform that's more focused on let agents have really distinct and powerful tools. And that means you can rely on the output of the agents in a much more accurate way. And that is where Synera helps in, because Synera is a low-code platform with almost 2,000 nodes right now, so 2,000 functions. You can create your own tool to help this agent execute these functions better, and also kind of lay out a system to guide these agents act on this autonomy and achieve their goals. So that's how I see it.
Mm-hmm. Sam?
Yeah. So to kind of dive into some of so Ram's using this word tools that's often associated with agents, right? So like this is the kind of thing where that allows agents to take actions. And what the agent's actually doing when you're designing these systems is usually telling it, okay, these are the inputs that you need to feed into this tool. Like maybe it's a series of numbers, maybe it's 2 numbers and a file that needs to be uploaded. And what Synera brings to the table is this ability to package engineering workflows, or workflows in general, as files. And those, they could be arbitrarily complex or simple, right? Like you might, we work a lot with CFD and computer-aided engineering workflows. So you could have this complicated set of steps where you take in a bunch of input parameters, go through a whole meshing routine, get all the way to CAD drawings. But the component that's important is that they're all packaged up and exposed at either end as a set of parameters. So you feed a set of parameters in and you get a set of parameters out. And this is a perfect concept to fit in with agents and tools, because really what agents and tools is all about is the agent deciding on what the right parameters to feed in are and how to interpret the output. And so by packaging up these workflows as Synera workflows that can then be run on a Synera run server and exposed as an API, it's just a perfect match for creating agents and multi-agent systems where you can even have agents that have access to their own unique workflows that all, I'll use quotes here, quote, see and think about the workload in their own unique way, based on the prompts that you give it and the personas that you give the agents. So again, the low-code aspect is all about building those tools and making sure that those tools give you the same answer each time. It's just code at the back end. So it's code that you can trust. It's non-stochastic, deterministic code. And then by giving it to the agent, it allows them to use that tools in order to solve problems.
Mm-hmm. How do you guys...
I love, Sam, how you explained Synera much better than I did. So thanks for that.
Great. I'm wondering, how does the mindset have to change from the engineering perspective when we talk about AI? I mean, there's a lot of misconceptions still out there when it comes to AI itself. And now we suddenly talk about AI agents and AI swarms. So something much more complicated, it seems, at least from a conceptual point of view. How do you think engineers can much more easily adapt this kind of concept of AI and AI agents? What can we do as organizations to facilitate kind of the adoption? Maybe Sam,
I can...
Oh, Ram, yeah, go ahead.
Yeah, sure.
Go ahead, Ram.
I think as I am someone who comes from a classical mechanical engineering background, the way I started out was treating it as another layer of automation. So I, as an engineer, have tasks that I want to automate. Some technologies are right for the right problems. And what these LLM agents have enabled is to unlock another level of automation. And I think that's the kind of value we see, or that's the mindset I guess we need to have towards agents, not just a technology, but where do they come into everyday life? What is the tangible benefit that I, as an engineer, can get out? And the way to that is classically what Synera has been doing for multiple years now. Let's think in terms of processes and better make it an automatable process. And we have a bunch of tools that are best for one certain degree of problem. The agents are better for another degree of problem. And I guess having that automation mindset helps for any kind of automation that exists and may come in the future.
Yeah. And the way that I think about it is, and I'll kind of like, we went over definitions of what an agent, but I'll kind of take a step back and like try to give an understanding of how I view them philosophically. And I kind of see agents as at some level just human simulators, and that's what we're all moving to. Like we have these agents and we're putting in structures that mimic human memory, and the fundamental LLMs that run them are brains that think in text and are ultimately based on architectures that replicate the synapses in human brains. So that's where we're moving, giving them memory, giving the ability to do things. So they're ultimately human simulators. So the way that I think about integrating it in any workflow, but including engineering, is thinking about using them as mimicking processes that humans are best at. So where you could separate out things like we talked about that CAD workflow, each time you need to go through a meshing procedure and then you need to go and feed it into this simulation, et cetera. If you can encapsulate that into a structured workflow, like where does the human come in? Where does the engineer's thinking typically come in? And the other way I approach it is don't always think about it as replacing people. Thinking about it as just getting more out of yourself and those around you. So you think about replicating and simulating humans. The other thing that they're good at is when you start talking, I think you're using the term swarm. I usually like to use multi-agent systems. If you think about building these multi-agent systems where you're putting two human simulations together, well, now you're simulating the interactions between humans. And why could this potentially be valuable? It's not just always about problem solving. It could be like, hey, I know Ram has a special expertise in tools in something, but he's on vacation for the next 2 weeks, and I would really like to not wait to get that answer from him. I would like to move this project forward now. Can I talk with potentially a digital representation of Ram, get access to Ram's team's tools that his team's responsible for making the tools? I'm just like interacting with that digital copy of him. And those are the kind of things that I think are going to be super valuable in the future, is really approaching them as digital human simulations and working from them from there. So I would say like, once you start thinking about it in that way, you could start seeing, you start to see, okay, I could use an agent here. Oh, I could use an agent here. Maybe I need to put together my Ram and my Sam agent to work together to solve this problem that we would normally be solving together.
Yeah, you mentioned the keyword or the word memory, which I think is very interesting. When we think about memory in terms of short-term memory and long-term memory, do you feel like that AI automation is kind of the short-term memory as compared to AI agents, which have like a long-term memory? Or how do you see that? Would you even compare those? Is this even a relevant comparison in terms of engineering?
I don't think so. Usually when I separate out short-term and long-term memory, it's more about like if you think about this from a systems perspective, when you prompt an LLM and you get an answer, if it's just an LLM that has no memory, it won't understand how to, continue that conversation. So I always say like let's say you ask it, what's the weather in San Francisco today? And maybe you get an answer because it has a tool that could access weather. But if it doesn't have memory and you say, what's the weather tomorrow? You'd be like, well, where are you talking about? I don't know anything about San Francisco. So by putting that short-term memory in, you have the ability to have a continuation of individual conversations. And then long-term memory is where you're trying to have the continuation of that conversation effectively indefinitely, where you want that agent to be able to not only remember things that have happened in the past, but also potentially, if you want to get very complicated, like in reality, it's a little more complicated than just short-term and long-term memory. Like you have all sorts of ways of structuring those two different kinds of memories, where you want the agent to be able to potentially member key facts about individuals, replace facts and make new memories, draw inferences from sets of memories into a separate categorization of memory. So I usually think about them as giving, again, just we have memories as humans. What do we use memories for? We use memories such that we could pick up tasks 2 weeks later. We use memories to be able to learn from our mistakes. That's a critical aspect of memory in agents. So really, we're kind of using them in agents for all the same purposes. And like I said, yes, short term and long term are mechanically different, and you treat them differently in terms of building the systems. But I think ultimately it comes down to just giving the information, making the context for any individual call to that agent, giving it the context it needs to best solve the problem at hand.
Ram, would you add anything here, or do you think that's...
Yeah, I think Sam put it a nice way. It depends on the level of execution and the maturity of what's in the memory. So for in context, while you're having a conversation, you probably don't need that much focus on, in the sense, memory. But if you let these systems deploy today, and you want to kind of digitalize a replica, like Sam mentioned, have a Sam replica or a Ram replica, you need to have a long-term memory that can remember interactions and stuff on a long-term basis. So I see it as an evolving perspective. For as of today, the applications, because the whole long-term memory is a relatively new field. There are different ways you can structure memory. There are different ways to retrieve this memory. So I think there are still some technical challenges out there, people that are trying to solve. I think as of today, we can start with it, but to reap the benefits, it's going to take some time.
Yeah, I would be interested. Maybe a follow-up question to this point is a lot of companies talk about when it makes sense to implement or adopt AI, right? I think what would be interesting is, where does AI automation end, and where does the process of, or where does it make sense to start implementing AI agents? Do you feel like there's kind of a rule of thumb? Maybe, yeah. Well, what's your process? How would you approach this problem? Maybe.
Yeah, I can start taking that. So I guess I see agents as a subcomponent of AI automation. So I think AI automation is the umbrella term. Agents are a component. So like, where does, one piece of when do you start implementing an agent as compared to like a normal artificial intelligence or machine learning workflow? And I do think that one of the big places to start is every single time in this system, I could follow the exact same steps. If for instance, you think about your standard original retrieval augmented generation pipeline, where user puts in a query, you know that you have to embed that query in vector space, you have to perform a retrieval from a vector database that's associated, you have to take the relevant passages, search for them, you have to take that relevant information and synthesize it into a step for a user. But it happens the same way from a steps perspective each time. Now, obviously, there are now 700 different ways of doing retrieval augmented generation. There's no one singular way to do it all. But that was kind of the way that it started. And an agentic application really are really good for, I don't know exactly what steps need to be taken to solve every single problem that could come into this system. So you think about all the ways that humans ask problems and write input queries in natural language. There are lots of problems where sometimes it's not okay to follow the same steps. You might need to maybe you have a multi-agent system and you don't need to talk to all the agents on every single term or every single query. Maybe you just need to talk to two of them. Maybe those agents need to go back and forth with each other and iterate. So like, let's say you want a system that's trying for Sam and Ram to write a blog together. How do we do it in real life? Well, someone starts a draft, maybe we split it up, we pass it back and forth until we are satisfied with the results, right? So that's kind of difficult to replicate in a non-agentic system, because you could say, oh, let's just do 3 iterations and then it's done. But that's not potentially great at solving the problem, right? So you need a system that can go and judge when you're done, judge whether or not it needs to keep going, judge whether or not you need to make potential iterations and maybe talk to other components of the system. So it's really that do you need fixed steps each time? Or do you need a more flexible approach where the system needs to determine at runtime what steps it's going to be taking? And not just at runtime, but like within the actual execution of the system, as things happen, the system needs to be able to react to that and understand what to do next as individual components of the system kind of resolve themselves.
Maybe, Ram, to give engineers who are listening to this podcast kind of concrete examples, what would you advise engineering teams when to start implementing AI agents? Do you think there's kind of, again, like a rule or something that you would recommend to people? How I see it, maybe just my 2 cents here, is maybe kind of the crawl, walk, and run approach, right? Where you conceptually show that AI agents are capable of solving at least something, instead of like just jumping on the AI agents hype train and just solve anything or want to solve anything. How would you approach this, Ram?
Yeah, sure. I would just build upon with what Sam mentioned. So Sam mentioned what are agents good at? So they are good at, let's say, not just being confined to rules. So automations are usually rule-based. So you give an input, you have output, there is only this fixed set of way to go. And agents have the autonomy to pick maybe a sub-portion of this step or skip it or so on. And I think the second important point I see with automation versus agents is the input, the kind of data that we feed into the system. So for example, if you have an automation, you need to have specific inputs defined. So for example, it could be automation that says add 2 numbers and create a sphere. So your input is right now just numbers. You cannot go to the system and talk, hey, what do you think is the best set of numbers to get a beautiful design? It's not going to work for automation. For agents, you could put this as your input. What do you think is going to work as a kind of set of inputs that you think is better for this challenge? So you see, we actually don't give it any input starting point, but the agent can then infer, or in this case, the agent is basically the LLM infers, what is this challenge? What can I make out of this unstructured data that looks interesting to me, but I need to also trigger this automation. So I also see this part as something really valuable because engineering requirements are like this. So usually engineering requirements start, at least in the OEMs that Synera works with, there's like a 60-page document that sometimes comes in as a starting point. And usually engineers read through this for days, then they set the inputs for the automation. And I see this kind of ability to take unstructured data and in seconds meaningfully trigger a set of tasks as something really valuable. And this is the point, I guess, it also makes sense to talk about agents or LLMs. Like Sam mentioned, what kind of human tasks are engineers doing today that is only solved by humans and not other tools? And then we can see which is potentially best for LLMs to be used. And once you use LLM, you could also pair it with a tool to make it more robust and scalable. So this is how I see it.
Yeah. Can you guys give a concrete example, maybe a case study, if you can talk about it, obviously, how maybe companies used AI agents concretely?
Sure. Maybe let me start and Sam can add his thoughts because we worked on this together. So a typical case is a request for quotations. So we usually what happens in this RFQ process is teams get like a business facing quote that, hey, we have someone like a OEM asking a tier 1 supplier, hey, we need 7,000 parts with these engineering requirements. Can you give us an answer? And traditionally what happens is this comes to like a sales team or application team. They have to translate it, contact the right product group and give, hey, we have this kind of engineering requirements. Can you please design a product? Then they wait. And then they have to fetch the results and maybe give it to a manufacturing team. Hey, we got this quote here from a potential customer. This is the answer that product team came up with. Can you guys please help me, or guys and girls, please help me figure out a manufacturing setup, how much it's going to cost, do we have the suppliers, and so on. So you see, it's a lot of back and forth. It's a lot of communication. And the worst thing, this cycle will keep on going. And this is a very interesting problem that agents can solve better because at least they can co-pilot these human engineers. When you pair every human engineer with an agent counterpart, you can ease this communication and improve the velocity at which teams can work and respond to these business requirements. So that is something me and Sam work with. Maybe Sam can also add a few thoughts here.
Yeah, I think that request for quote project we work on is a great example of this, right? Where you have this team in real life, maybe 5 or 6 teams that have to get involved to come up with this quote. And that's just the initial quote, let alone follow-up questions. Can you compare 2 quotes by changing? Yeah, maybe we have 2 different iterations of this system with changing a variable. Can you give me comparisons of these quotes? And as Ram was describing, in real life, that request for quote might take dozens, hundreds of human hours over the course of who knows, weeks, months. You never know. So what we see with these systems is think about being able to use this system to just in a couple of minutes simulate that process, simulate those teams interacting with each other, simulate those teams talking with each other, sending inputs to each other, refining those inputs, and ultimately synthesizing that request for quote. And as you see, we saw it in practice, when you're watching the simulation, you also can get an auditable trail of what all the decisions that are being made are. So you think about in real life, instead of having, okay, we have to schedule this meeting and get it on the calendar. Oh, we're really busy. Oh, maybe this person's not here. They're on vacation again, and this process plays out for weeks. Even if you could just simulate that to give yourself a starting point, and then all the teams can just go on their own, potentially asynchronously or synchronously in one single meeting, just say, hey, does everything check out here? Let's just read through all the decisions and see, like, is this what we would have done? Is this right? And you think about now taking a process that might involve 6 teams over the course of a month and just squishing that down into one simulation that everyone can just check. And maybe you have to iterate. Maybe it's not right 100%, but think about how much time you've now saved. And now you can get that request for the quote out to your customer that much faster, in maybe an afternoon instead of 2 weeks. And that's really what we're focusing on. Again, it's that simulation of the interactions of humans to try and increase productivity.
Mm-hmm. In terms of business adoption, Sam and Ram, I'm thinking, why do you think some companies struggle with maybe adopting AI in the first place, and then let alone AI agents and AI swarms? Do you think it's like the uncertainty that comes with it when adopting new systems? Because it's sometimes maybe hard to calculate an ROI on a specific implementation. What can businesses do to actually start adopting or playing with AI agents today?
Me and Ram have been thinking about these things as our full-time jobs for a long time, like for a year plus now. And so I always recommend people just have patience, like keep your nose on the grindstone, keep working at it. You mentioned earlier, Yusuf, you use a phrase I love to use is crawl, walk, run. I'm a physicist by training, so I always got taught to solve the one-dimensional problem before moving on to the 2 and 3-dimensional problems. If you try to jump right into the 3-dimensional problem, you're going to have a bad time. So I always recommend starting with just create a simple, think about setting a goal where you have a single agent and a tool, and make sure you understand how that works, where it goes off the rails, how to bring it back on the rails, because these are just all techniques that you have to learn over time. And we're, as a community of people around the world that are trying to understand this, we're all trying to just understand these things right now. These things, the LLMs as the brain of these systems is such a new concept that we're still all just trying to figure it out. So I would say for anyone that's trying to do it, don't try to rush into a multi-agent system. Just because that's the cutting edge right now. Start with the basics. Try to help wrap your head around the basics, and get something you trust, and be practicing all the time with them. Use one of my favorite things to do just to learn LLMs is just learn how to prompt. So be using, even without doing agents, just use an LLM every day for all your tasks, for writing, for problem solving, for learning. I use it for learning. I just go on long walks with an LLM and I'm just asking it questions to try and teach me things, right? So you have to kind of start with those basics and fundamentals before you want to get into the more complicated systems, but that will come. It will come one day, and I do think that there's tremendous long-term ROI, but I think you have to think about it in terms of long-term ROI and short-term ROI. If you're looking to just try and get something cheap and quick out the door just to have a Gen AI product tomorrow, you can probably do it, but it's going to be basic.
Yeah.
And there's nothing wrong with that. There's nothing wrong with that. It might be good to think about it in two buckets, and it's going to take research and development time for all organizations to really get to the most complicated systems.
Mm-hmm. Ram?
Yeah, I think very beautiful advice from Sam, and also like Yusuf, you mentioned. I think it's a great approach. I see it also as a great engineering approach for any system, not just for agents or we don't know what technology is going to come out next. I think it's going to be always a guiding principle. And on the business adoption side, I think one fact that we also all have to agree is right now, if you look at organizations around the world, AI adoption is uneven. So maybe it comes at a geographical factor, it comes through other factors, but AI adoption is not even around the world. And usually, what happens is, like Sam mentioned, people who try out things faster, learn faster, they can iterate faster. And I think that is what we are seeing. So we see some companies, or I mean, this is at a more business level. People have a very good use case or a problem to solve, and they are highly focused on this problem. For example, it could be this RFQ. It can be increase the time for concept development. And what we see is people try out different tools to solve this exact problem, and I think that will work. Instead of taking all different tools that come out and see what problem can it solve, I think at least organizationally it makes total sense to me that organizations are focused on what do they want to achieve, and then keep evolving their tools and technologies to solve that problem better. And as far as I get to see it, I think this adoption is uneven all around the world.
Yeah, I love that. Maybe to wrap up the podcast, maybe one last question is, what would you advise people, especially people involved in maybe deploying AI systems or AI agents in their departments or in their business? How could they get started using AI agents? I mean, you gave a couple of hints there, because I think if we go on LinkedIn, there's a lot of noise, right, nowadays, or on X, for example. So what is actually possible and what is not possible? Maybe you can give people some boundaries on what AI agents are not capable of and what they are capable of, and what resources you use yourself to learn on a day-to-day basis.
Yeah, sure. I would say try and understand the basic landscapes of building agent frameworks. Like pick a couple of different ways you could build. So for instance, like AWS has Amazon Bedrock, which can be used as an inference engine, which is the backbone, or really the brain, I guess is the better term, for any kind of agent. There is Amazon Bedrock agents that you could use to help create agents. There's open source alternatives like LangGraph and LangChain is one that I really like. Crew AI is another one. So kind of pick a couple, get an understanding of what that landscape looks like, and start again very simple. I would say if you haven't started with a system that has a single agent, and add a tool first, and then see what you have to do to make sure that it calls the tool or doesn't call the tool at the right times. And a couple of like other just smaller tips is like always make sure as you're building and testing, like always want to test and observe the system. So use something on the side that allows you to see what are called traces, which is usually as you're going through the system and you're understanding, okay, because often an LLM or an agentic system is going to be multiple calls to LLMs. So whereas if you're just calling an LLM, what's called zero shot or few shot, you're just making one call, getting text back. What these agentic systems or even single agents are doing are making multiple calls potentially over and over again. So you need to be able to see, okay, at this call, what was put in, what was put out, what decision was made, then what happened? Did it execute this tool? How did that go? What did it do? Make sure you're always working with an observability tool on the side so you understand how to debug and where your system is going off the rail. And one final tip before I'll turn it over to Ram is use LLMs to construct your prompts. There's really good research out there to indicate that LLMs like agent systems are at some level just elaborate prompt engineering structures. So use your LLMs to generate or to improve more so. Like if you draft a prompt for your agent, feed it into an LLM, say, hey, I'm using this for an LLM agent. Can you help me adapt this for optimal use? LLMs are just as good or better than humans at actually constructing agent prompts. There's published research on that to kind of prove some of these points, but yeah, I always work with an LLM by my side as well. So observability and work with an LLM to actually design the prompt in the system are two great tips, I would say, that you can start, just from day zero, from day one, building these things. You should probably adopt.
I love that. By the way, one quick question, Sam. Do you also use kind of this chain of thought prompting, like implementing it into AI agents to kind of see what is the LLM thinking about specific tasks, for example?
Yeah, it depends on what kind of agent you're trying to design. So, like, if you think about I call it the classic. I think it's only 2 years old now, but the classic agent is the React agent, reasoning and action, which is at some fundamental level, like I said, it's a prompt engineering technique where you are using chain of thought. And for any of your listeners who might be unfamiliar with that term, chain of thought really is kind of a process where you're asking the LLM to take a problem and break it down into a series of manageable steps. And then reasoning and action effectively is, as we execute that, you execute step one, you see what happens, and you say, do I need to change the plan, or is it time to go, like, can we stick with it? So you're kind of understanding that input in real time and dynamically potentially changing the plan. So chain of thought is a very common technique that's used in agentic systems, but you're also now seeing chain of thought come out. Like, it's a useful technique, for instance, the reasoning models that are very popular right now. The reasoning models aren't always necessarily agentic in nature, but they can still have a chain of thought prompting to help them solve even just a text in, text out problem. So yeah. Chain of thought is it's a foundational concept of building agents.
Great. Ram, you have the last word.
Yeah, sure. I think Sam again put it nice. I'm not sure if you know this famous Thanos dialogue from the Marvel. I use the stones to destroy the stones. So I keep saying this, use LLMs to learn more about LLMs. It's a great starting point. We don't need to go enroll in a big course. Just I think that was also my starting point, to be honest, when ChatGPT came out in December 2022. I just wanted to just play around, then picked up things faster on the LLM side. And Yusuf, I think your original question was more on the practical implications, what's going on the hype and what engineers or we can know better. Again, I think Sam mentioned it already. So when we have these terms called, you do a development and then you have DevOps. You do machine learning applications and then you would have ML ops. And what we are seeing when we push these systems to production is you have LLM and now you have LLM ops. So you need to craft pipelines, you need to craft systems, or this observability that Sam mentioned. This all comes here. And that's why I want to underline the fact that POCs are easy and it's a great starting point. We definitely need to do that. And the effort to really bring that system into production would be not to be underestimated. Or the easiness will go down rapidly as time goes on. But I guess at least what I learned was the LLM ops, especially the auditing, the observability, checking the latency, checking everything is something that comes when you want to really make use of these systems. So yeah, I actually also learned from LinkedIn, even though there is hype. But let's just check out good papers and just try to have a mathematical connection to the whole world of LLMs.
I love that, guys. Thank you so much for the great discussion. I'm sure it's going to be a great podcast. People are going to listen to it very intensely. If we have any resources from the AWS side or Synera side, I'll put them in the description of the podcast so people can check out further resources and educate themselves on the topic of AI agents. Thanks so much, Sam and Ram, and I hope there will be hopefully a second part in the future.
Absolutely. It's a pleasure to be with y'all.
Thanks so much.